Great. So good. So welcome back to the channel. Hope you're having a swell time, and thank you to the new subscribers in the channel. Welcome aboard. And today, as the title suggests, we're doing weldment or welding drawings. So I have a pretty big part, as you can see here down below. It has 4 pages, but the first one is pretty easy. It comes to show you like more or less what it looks like. This is a structure. Doesn't matter what it does, doesn't matter what it is. And you can see here these 3 are missing because I'm missing some parts in my part library, but it's not important. Yeah, let's start. I have to say that welding is it varies a lot between workshops and between countries, but these are the basic things you will see. Like basically we're gonna ignore the fact that this also has measurements like these and this. Like this is a 4.5 meter by 2.5 meter part, right? But the reason this is drawn like this is because the person who's welding it, like if you look at it from a database perspective, like you're the engineer, the mechanical engineer, designer, whatever, and you're ordering a part, and you go to a contractor or whatever, a workshop, and you tell them, I want this part. You pretty much have to specify these things, these measurements, because the way it works is first they collect the parts, then they weld it, like they weld the structure together, then they do, like they drill these holes and a bunch of other things like these. These wouldn't be drilled before the part is already welded, but you as a person, like you are ordering a part, one part, and as I said, from a database point of view, this is just like one part. Its name is whatever, process chamber weldment, and it has these sub parts, and these sub parts are like, they're not official parts. They don't have their own drawings because their own drawings don't matter. Because when you for example, when you weld A15 or A8, because of the thermal stresses, and there will be warping and there will be changes, and what you want to have in the end after welding are these measurements here. Like you don't care before that, basically. You want these and that, and whoever is manufacturing this has to make sure this correlates after they weld. Like maybe they have their, whatever they do, they could cut the parts a bit bigger, weld, and then they can machine it down to the measurement, to the size you want. Basically we have here, if you want to know, you can go to weld symbol, then you can add like you can add on one side, yeah, you can do this and that and tell it to be A8, and you can also do all around, and now this one is somewhere, here it is. You can also do A5 over here. Like this is pretty, you can do whatever you want, more or less. Now if we delete this and we tell this one to be nothing, yeah, it's called fillet. Okay, good. So you have fillet. These all are very like standard A8 fillet on one side. Does that mean one side or two sides? Yeah, this is just one side. You could also, like, the standards vary from country to country, but basically from the way I learned, this would be both sides. Like when you are referring to this spot, so the other side would be here, there has to be a way to communicate with one arrow that you want it here, but basically this circle should mean around this seam. So this is basically, it should either be here, up here, or this shouldn't have the peripheral, like the all around sign. As I said, a lot of people have, this is not a drawing I drew, and the office I worked at where this was drawn used I think it was a mix of standards. Let's see what else we have. Yeah, you have here A2, wait, section FF is, there you go, here. So this thing here is this hole, and maybe I'm missing a part here, but basically this is an A2 fillet, and this is 30 millimeters welding, and then 25 break, like empty, like not welded. Here you have 20 and 15, 12 and 12. These parts are missing because, yeah, as I said, I'm missing some parts in my library. And this here, when it says hole, it's you don't need to write this. What else do we have for welding? These are V welds between this and this. You basically, I think it needs a bit more information. Yeah, just writing V doesn't work, but it works when you are working with a workshop that knows what they do and what they're doing and stuff, but this is not fully defined. Basically, you would have here, this is the material between the two parts, and you would grind a bit on this side, grind a bit on this side, take a bit of the material away, and then fill it up with the electrodes, welding. Yeah, this is not like, this means 5, like 1, 2, 3, 4, 5 on each side. So 5 here, 5 there, 2 for the sides. So 1, 2, and 1, 2. And this is definitely missing some information. What else do we have? A15 here. A, you know what A means, right? Welding. Yeah, good. All right, so basically, this is the A, and this is the Z, usually. So when you give an A indication to your weld, you're naming basically this length, meaning that Z will be much bigger. Well, not much bigger. It's times 1.4, if I'm not mistaken. What else do we have here? I think I will have to load up another one. This drawing is a bit boring. Let's see. What else do we have? Oh, what a mess. So more A8, A8. Basically, you can get rid of this one and just like both sides. If you this basically means the corner like into the screen from here, and this one is on both sides. It's a bit of a wonky way to write this. Like I would expect this one to be from the side, but whatever, it works. Like it's the welder will understand what you mean, and if not, hopefully they will ask. A3 both sides. This is the surface machining, which is not for now, right now. So yeah, it just looks massive. A lot of these drawings will look massive as hell because you need to put so much information into this crap. Like all the afterworks, like all the drilling, machining. This thing is like 4 meters long. So there's a lot. You've seen it on this side here. So many holes and features and things, and here you have a little surface that you need to machine and then drill the, and everything is tolerance and stuff like that. So it's kind of massive. But from a welding point of view, there's not a lot here. Let me check. Do we have any tolerances? All right, cool. So a bit of a simpler one. And this drawing specifically I drew. And so this is just a frame to hold the part we just saw. To be honest, so. Most of the things are A3, so this is a good example. We are looking from this side, and we have the both side, like A3 on one side, on this edge, and then also the other side. E, what is E? E is here, so if we look from the top, basically, this edge here, this one, this dot, is here, and the other side is here. So basically I could put two symbols, A3 here and A3 there, but you can do it with one symbol, which is arguably easier. Arguably. And what else do we have here? What else do we have? This is A3 all around, so around these edges, and a fillet weld. These here, very simple. You like just welding this part on the side. This is to like, this is not very structural. It was for a different reason. This thing here, and to be honest, should be over there. This part, this thing here is these little adapters. Like you weld them onto the frame, and then these are drilled, I would say, after and they are welded. And this is not the drawing I wanted, actually. Maybe this is the drawing I wanted. Okay, good. So we have a few more things to see here. One of them is a cut table. So these are the positions. This is a, let's call it a weld table. It's a weldment cut list. You can, if you do the weldments correctly in SolidWorks, which means, yeah, it's a bit of a tangent, but it's relevant. If you do a weldment, and then you do a 3D sketch, and you define it, like this is a 3D sketch, pretty simple. And this card changes, and then you assign a profile or a, like what part it should be, what kind of profile the beams should be made of, which you can define, and that's a completely separate video. It's very simple, very cool actually, the way it works. If you do that and you define, for example, these junctions, like you see when before you define it, it's like that, and then you can, let's see if I remember how it works. Yeah, here you can define how the edges work. Like you can do this, you can do this, you can do that, you can do this. This is what you usually do for this kind of construction. And then you have it's a rectangular tube. It's 120 by 80 by 6.3 thickness. Then you have the length. Then you have 1 angle, 2 angle. And let's see the position 1. Yeah, it's this one. So there's no cutting. And this one here, position 2. It's this one. So it's the same. All of them are the same tube, same profile. And this one is 40-50 millimeters, 45-45. How do you define the 45 or minus or whatever? I don't really know. No idea. But there should be some kind of what is it called, consensus, or they should at the very least, look at the drawing and see what they need to do. Anyway. So they should receive these parts, and then it's like IKEA. And basically you need to stand them together, like match these and match these. And while they are doing this, they should also take into account these tolerances, right? Whoops. So where's A? A should be, if it's perpendicular, it should be at the top somewhere. Yeah, there it is. Okay. So when they put the structure, like they dummy assemble it without welding it yet to see that all tolerances are okay. Although 0.5 is pretty loose of a tolerance. So they check these, they make sure it's within what is allowed, what the designer asked for. Then they can start welding it. Like you can see here, A3 around. To be honest, now that I look at it, it should probably be a V weld, probably. And what else? Like as I said before, you will almost always have holes and other, like in German it's called Nacharbeitung. All the things you need to do after are also there. Like these holes for later on, this is for the motors. Whatever, there are motors, deal with it. These ribs to strengthen the structure are also there. This is the position 4. Yeah, it was this one. So 140 times 140 times 6. These are probably being just cut on the spot before welding, and these exist there. We have these rectangles here that are like empty, because here there will be a weld, there will be a seam, and you want to have allowance for it, right? Actually, there's another thing I wanted to show. In Solid Edge, it's super cool. I don't know how good it is here. Let's see, weldments. We have weldments here. No, I want welding. Fillet bead. Yeah, so basically you can, theoretically or technically, you can click these two and tell them like, I want a 3. You have to go to phase 2. Then, okay. Okay, yeah, I was at the wrong place. Now, you have here a weld folder. And this one is pretty bad. Let's do... you can do all the things we talked about, like you can do a broken weld. It's cool. But then... oh no. This I don't want. So this, it's not a good visual representation because I cannot see it. And it doesn't add the material. Like, it doesn't add the seam, the fillet. Let's do another one. What's a gusset? A gusset is this thing, okay. And let's try this and this. Let's say 15. And that's what bothers me about this. It's just, it doesn't show you the triangle. And let's see if we can see it in the drawing. Also no, so it's kind of silly. It's kind of silly. Can I have add tangent propagation around selection? You can define the symbol here, and let's say A15, and we choose this thing. Whoop. Let's see if it shows up on the drawing. Yeah, that's the problem. Rebuild. In Solid Edge, you can define a seam like this. It will also generate a geometry and weld symbol so that you can go to the drawing. You can select this, like you will have a little rectangle, right? Let's go here and do, like, you will have this thing. It will be black in the middle, in between, and you can call it out, and it will. You can define the seam. You can define the seam in the model, and then you just call it out. And whenever you change the seam itself, it will change on the drawing. Here, all of these are manual. This is bad. Like, this doesn't allow for easy changes. But yeah, I mean, I think there should be a way to do something like this. I just don't know it right now. You can add a gusset like this, like that, or like this. Let's say 200 by 200, right? And you can also do this, and you can choose this, and you can tell it like let's say 20 times 20, which is cool. You can also do with degrees, whatever you want. You can change the thickness. Yeah, this, like, these are parts here, I think. No, these were made with gussets, so you know, pretty easy, pretty cool. And then these come here, and you don't need to draw them. You don't need to do most things. Like, it's pretty automatic, pretty simple. It just counts how many you have. Super simple, barely an inconvenience. So these you should already know from the previous, like here, or the previous video if you happen to have watched it. And yeah, basically that's most of what I had to say about these are very simple weldments. There's nothing crazy here. I will try to find more interesting, more juicy drawings to show you. And yeah, I will see you in some other video. Don't forget to hit like and subscribe if you want more of this. Thank you. Goodbye.